Yes.
Ah! And wasn't this also the chapter with the unit circle?
Yes.
Ah! Which means this test is going to have a calculator and a non-calculator part to it. Oh, so will you be able to use calculators on problems like 4.8? Jaden, you might want to hear this. Are you going to be able to use a calculator on this stuff? Yeah.
Yes.
Are you going to be able to use the calculator on a unit circle question?
Maybe.
No.
Never. So, be aware.
No, it's tomorrow.
Oh.
Not the entire test, but part of
The
it.
history test is tomorrow too.
So is the chemistry. Oh, never mind. It's not.
Hey guys, this whole efficient use of your time, it's not happening right now. So shush and focus and let us work together to make tomorrow the best possible test as possible for you. Does that make sense? And yes, I said as possible twice. Number 6, the final answer. Well, I think you were doing a couple different things, or a few different things. 12.14 and 8.82, and if you were amazing and had 3 decimal places, just think whether your answer rounded would match up with these. Oh, P.S., the missing angle was 36.
There was a few, I thought.
A few.
Oh, we will have to do 90?
Well, 90 was assumed. I mean, you could have written 90. That's
If it has a
fine.
square, it's automatic.
Okay, number 22. 81.2 feet. They said approximately, which means they rounded. I don't like that rounding, but that's okay. 81.2. Number 34A. Hey, did you see them use feet per second and have to change it to minutes to work with the 1 minute?
No, actually not.
Or you could have just multiplied by 60 seconds, thinking 1 minute is 60 seconds. But you needed to figure out that it went 16,500 feet to be able to have your hypotenuse to solve for the opposite with sine. There he is, 5,099. And letter B was a little bit weirder because they told you that 10,000 was the, is this elevation I'm guessing? 10,000 was the elevation or the height, and so you were trying to figure out how many seconds it would take. Which is a little bit weird unless you realize that you could have just gone ahead and solved for this and then said, hey, divide it by 275. Anyway, long story short, there's a couple different ways of getting that. 117.7. 40 was a weird one. He was a bearing one. But if you guys took the planes north, oh, they didn't give a, oh, hey, is there another way of writing this angle? Okay, this is the bearing, turning clockwise from north to south. But what's another way that you could have written this angle? Maybe using south and west? Here's a picture. What's another way of writing this angle? Maybe using south and west? North, east? No, I need the angle to be the same.
Oh.
Using southwest. What would be the angle?
Like a quadruple?
Kind of. A different way of writing it.
Wait, it would be 45.
28. You see why?
No.
It's 180
Oh.
and 28 more, so it would be south 28 degrees west. Wouldn't that be right?
Where did you get 28 from?
The little label.
Geometry. The whole thing is 208, and isn't 180 a straight line?
Oh, okay.
So then you subtract, and then you get that additional piece. That's that little curvature past south.
So I just have one question.
Yeah.
Why are we not using the big compass? Somebody using the little circle that's.
Oh, because it was asking for the planes bearing. So remember Emily's question yesterday, she was like, well, how do you know what's north and what's east? Because it depends on where you are. Because if you're on the east coast, then what's east of you is like China. Or maybe China's west. So you have to think about what's your reference system. So they said, what's the planes bearing? So I can't go looking at the airports north, south, east, west. I look at the planes north, south, east, west. Does that make sense? Yeah, Bianca.
I think I was good after because I think I have to show you.
Okay. Jade.
Why is it, I'm confused, like, 208,
Oh, well, you would have had to solve. Sorry. It's 208 because they told you these hints about the 85 east and then the 160 north. I'm guessing were the hints. I don't have the problem in front of me. But they gave you these hints, which was is an opposite and adjacent to this dude. Oh, forget it. This would be easier. An opposite and an adjacent to this dude. And so if you solve for this little guy is 28 degrees using tangent inverse. Remember, tangent says, give me the sides, and I'll give you the angle. So calculator could give you that. And then the way they wrote the bearing was that good old-fashioned, hey, the North Star, you can always find him. How much do you turn? And so that old-fashioned way of doing a bearing is you would have had to turn 180 plus the 28. Does that make sense? But you could have also done that, hey, isn't it just south 28 west? Technically the same. So,
I was gonna say, when it says what range you're keeping is an angle.
bearing is always an angle.
Oh, I put like east something.
You were thinking of the airport's bearing. You have to watch out for the wording. Because the airport, it is northeast of the airport, but it was asking for the plane's bearing. And so the plane's bearing is technically southwest to go back.
So it's just a plain angle without like anything.
Well, the angle they gave you was the old-fashioned way of doing a bearing from them. But the north of the plane, not the north of the airport. Does that make sense? The north of the airport would have been this, what, 62 degrees? Is that what you did for your northeast?
I'm not sure. I put 57.
You would have had to subtract from 90, I think. And so that would have given you the 62. Claire got 62.
Like, I think I did something. I did cosine inverse.
Oh, wait, my bad. No. Sorry. I didn't solve down here. Oh, that still would have been, this would have been 62 for this angle. So northeast from the airport, would have been 28. Huh. Maybe you didn't use these as opposites and adjacents and tangents? Did you use a different trig function on accident?
Like, I put the beta like next to the center. Like, yeah, I put that angle.
You got 57 something?
I put 160 up. Yeah, 85. So I
Give me the tangent inverse of 160 over you, okay? Over 85. Oh, see, you used the wrong trig function. Because when you draw your triangle, that's a hypotenuse. These are opposites and adjacents.
Oh. Okay.
So maybe like your reasoning was a little off too with the northeast thing. You were looking at the airport and not the plane, but your math doesn't even look close because you used the wrong trig. There you go. Priyanka, we need to answer your question somewhere.
Maybe, I'm not sure.
Okay. You can peek at it when we start doing work day. That sounds good. 42. Your final answer is 5.46 kilometers km. There's a little bit of different math that went into it. I'm guessing if you guys didn't get that, you probably want to ask about it. Oh, is that the end? That's the end.
Yay!
Okay. I have the book open. I'm ready to go peek at it, to go work on this homework deeper. If you guys don't mind, some people are like ready to go and just go for the review. Can we just, as a class, all together, talk about the test, get the details down?
Yay!
And then, if you're ready to talk about word problems, I'm ready to talk about word problems. If you want to work on the review, I can go for it. But pause. Remember, on the review, save time. What are you allowed to do to shortcut your time? You don't have to write don't write the directions or the problem details. Just get into it and solve.
Let the whiteboard bubble off the face of the earth.
I'll get off of it with you.
So every application of math just doesn't matter anymore?
Hmm?
There goes computers and rockets and anything with tech.
Did you ask?
Yeah, any sort of synthesizer. Sorry, no more.
I'll play acoustics, it's okay.
Finger here.
Did you ask Joe?
Who's Joe?
Oh, no, calculus, we were in the zone yesterday.
Who's Zoe?
And I didn't really talk to Joe yesterday.
Oh.
Oh, no, I did. He was showing me lots of things. He likes politics and
That guy's the white tag. The white tags be like Trump the whole time.
Test! Hey, focus! We want to be efficient with our time. Okay, so, 2 portions of the test. Ready? If I were you, I would make 2 columns on your paper. The non-calculator time is the first part of the test that you guys will have. Calculators start. Can we just be organized tomorrow? Is that okay?
No.
When you come in, what goes in the chart?
Phones.
What comes up on the table?
The notebooks.
Notes and homework spirals. Now listen, you're allowed to use your calculator on the test for the second part of the test. So can we all just open our calculators, because you know I don't want any openings of covers that might have stuff hidden underneath it during the test. So take off your cover and put them both under your desk tomorrow. Yeah?
Capiche.
Why is it going to be under your desk?
So you don't use it.
Because you're starting with the non-calculator part. When are you allowed to pull it on top of your test? After you turn in the non-calculator and I give you the calculator part. Then you can pull up your calculator and say, here we go. Sound good? So, phones, notes, spirals, calculator, under. And then you're just like, cover sheet, ready to go. Sound good? And we can scatter ourselves around the room. That way you don't have like this mess of people distracting you by then turning to those second pages. You're like, I'm still on the first page. Okay, here we go. You ready? Non-calculator portion of the test. You guys have 9 multiple choice and 1 long answer. Non-calculator portion. You might have some little baby ones like the unit circle quiz.
Baby.
You want me to give you an example? How about sine of 7 pi over 4? No, it's not the one on the test. You're gonna have some little baby ones. You're gonna have something maybe asking for a supplement or a complement.
Sorry.
Maybe some periods and amplitudes, like, you know, those waves and how they had all these different pieces. That could be a great multiple choice, is asking for just like a little piece here, a little piece there. Hey, for tangents and cotangents, their graphs were kind of gross, right? So what if I tell you on the test, the only thing you have to know about tangents and cotangents as far as graphing is how to find their vertical asymptotes. P.S. There are steps to do that and little baby equations that if you have memorized will make it easy. Hey, this looks a lot like one of the notes. Anyway, okay. Tangent and cotangent, just know how to find their vertical asymptotes. Hey, should you be able to do an arc trig and inverse trig backwards if it's a unit circle, dude?
Yes.
Okay. Just make sure you know how to find the legal one. Remember, inverse trig just gives you one answer. You can't just give any answer. It has to be the one right one, the one in the right quadrant. Hey, did you figure out from yesterday how to find bearings, like what quadrant they're in? If you're going south and then east, where are you? If you're going north and then west, where are you? If you're going south and then west, where are you? That's a great multiple choice question. If you're given a couple pieces of information in a triangle, should you be able to use either Pythagorean or SOHCAHTOA to make an equation to solve it? For whatever's missing. So you could be missing an opposite, an adjacent, or a hypotenuse, or you could be missing an angle. So either using Pythagorean, it's those find the missing piece type questions. I think you guys had one at the very beginning of section 4.8. Amplitude, period, shifts. That sounds like more of those transformation-y things with the graphs. And then, ooh, here's a good one. You ready? Given a point, I would literally write these words if I were you, because there are problems that match up with this that you could study in your notes and in homework. Given a point on a terminal side, find me trig. Trig. SOHCAHTOA, HPrecalc. Jaden, you did one of these yesterday. I gave you a point. What did you have to do to find the trig?
Everything.
Oh, triangle.
You had to graph the point and make a triangle and say, ha ha, I have opposites, adjacents, and hypotenuses. Given a point on a terminal side, I would go to your notes or go to homework because there were questions exactly like that. All right, you ready? Those are the 9 multiple choice. So what's the long answer? A big fat graph the wave and tell me all about his B, his A, his B, his C over here, his quarter cycle. And if I had to graph a wave, could I have you graph a secant or a cosecant real easy after that? Of course I could, because all I gotta do is bounce. No. For the final, sure. Unless you want it for this test and not the final.
No.
Yeah. Okay, so here we go. Calculator portion.
Oh.
Calculator portion. Can you change radians to degrees or degrees to radians? Good old-fashioned convert. Can you change radians to degrees or degrees to radians? And if I were you, maybe there's something in your calculator, but there's just an easy times 180 over pi or times pi over 180. Just gotta know which one's which. If I give you one trig function, I don't know. For instance, sine of theta equals 3 over 5. Could you find me all the other trig by drawing a triangle? Yeah, you could. If I give you a trig function, like sine of theta equals 3 over 5, could you find me all of SOHCAHTOA or CHPrecalc by drawing a triangle and filling in? Hey, do you guys know how to do cosecants and secants and cotangents in your calculator? 1 over. There is 1 over due, right? But what if I give you minutes or seconds? With your calculator, would you know how to put it in? Reference angles, they're a thing. Coterminal angles, they're a thing. Inverse trig with those nasty reciprocals, they're a thing. There's 1, 2, 3, 4, 5 multiple choice on the calculator portion and 3 long answers. One of those 3 long answers has to do with an arc trig of a trig or a trig of an arc trig. Remember how we put them together in section 4.7? Trig of an arc trig or arc trig of a trig. Something about a triangle. Section 4.7, it was a thing. Ladders, airplanes. Okay, I'm done.
Is there an actual credit opportunity?
Yes, on the non-calculator portion of it. And I said it, but I didn't say that it was extra credit.
Say it, no.
So it's in the list.
Do you have to have like the cosine squared or cosine squared?
No. No, it's not until chapter 5. It's not this. It's that huge old, well, okay, there was that big table of properties, but guys, not the Pythagoreans, but shouldn't you know that tangent, not really. Shouldn't you know that cotangent is 1 over tangent? Like, you know the basic reciprocal, guys. But besides that, good. Okay, if some of you guys just want to put in headphones and start working on the review to have questions to ask me if you get stuck, go for it. If some of you guys want to ask me homework questions, you may do that too. Calculator? Yeah, go for it. Yes, you do. Okay. But I'm ready if you guys have any questions, or if you want any sample problems, or if one of those things I just mentioned, you're like, what is that? Ask me about it, and I'll give you a sample. What do you want? Hold on, say it one more time. The weird. You don't have to convert by hand by doing lots of dimensional analysis with you. Does that make sense? But what did I say? You might have to do something like cosine of 37 degrees for minutes. Do you know how to put that in your calculator? How do we put that in our calculator? Look it up. Oh, cosine button. That's easy. What do you mean, Sophia? Second what? Oh, there's degrees. You guys saw minutes in there, right? How do I do the 15 seconds? You can go look in the second app. There isn't a second, and any of those won't work. Why did I hit the green button? You see the little quotation mark? Hold on, guys. What mode do I need to be in for this problems be right? Degree mode. Could there be any place on the test where they are talking about radians instead? For sure. So, be careful, okay? Because you might have to switch your modes at some point. Oh, and then, forget it. I think it worked. No, it did not work. What the hell? I'm on like alpha lock, sorry. Am I off alpha lock yet? I don't think I'm in degree mode. Yep, that's not gonna work.
That's cool. If you download games on that calculator, can you play it on that screen?
You can't upload programs, I'm just not sure if you can, but maybe. But just a quick, like, I can't go near as fast as you guys typing, so some of those games that are built on, like, it's gonna be a mess. Cassie, good question. Second. What else do you need? Word problems from last night? Questions that you don't know what I meant? Yeah. Tree of arc trig. I can find that. But tree of arc. Tree of arc trig. Don't mind if I seal through that. No, I'm not sure. Oh, there goes my voice. Where would he be? That's section 4.6. That's where it is in our notes. Trig of arc trig. What if I was to give you something like, give me some random HPrecalc function. Any of the 6. Give me something. Sine. Give me a different one. Now this one's a little bit nicer because he's a unit circle guy. So some of us could just literally be like, oh, I know that guy. Wait, you know that guy? Yeah, I know that guy. If you're a circle kind of person, you might know that this would be negative root 3 over 2 and negative 1/2. So maybe you get to the answer pretty quick. Because what's this question saying? Oh, no wonder it's so bad. Hold on. Arc trig. It's okay, learning opportunity. Arc trig doesn't take angles. I mean, it can, but it doesn't know what to do with them. Arc trig takes ratios. So was it legal for me to put arc cosine of 7 pi over 6? Angles go inside normal trig. Ratios go inside arc trig. So the struggle is I shouldn't have put 7 pi over 6. I should have put something like negative root 3 over 2. Now, okay, so this just made it a whole lot harder in some ways. Because sine at 7 pi over 6 is negative 1/2. But question, why is the answer to this question positive 1/2?
Oh, because it's negative? Right? Quadrant then?
What quadrant is cosine negative in? 3. And actually, no, cosine's positive over here.
Oh.
All students take calculus. Where's cosine negative? So am I needing, because of arc cosine, someone's asking me for a trig, arc trig. When I see negative root 3 over 2, doesn't that happen in 2 different places? In my unit circle, it happens at both 5 pi over 6 and 7 pi over 6. And sine is positive in that one and negative in that one. Why did I know that I had to be thinking here for my answer? In section 4.7, as you guys go back and review, the arc trig says there's only one answer to this. Cosine says give me anything from quadrant 1 or 2. Those are the only two places I'm looking. I'm not looking here or here. Arcsine would say I'm only looking in quadrants 1 and 4. It's important to know the legal place to look, or else you might accidentally choose the wrong one. So arc cosine of negative 3 pi over 2, the only angle that is legal for me to use as the one principal answer is 5 pi over 6. And so the question all along was, what is sine of 5 pi over 6? Which is 1. Arc cosine, any inverse cosine gives me a ratio. There's only one proper angle, even though there are infinitely many locations. There's only one inverse angle that is pointing to. I take the trig of the angle and I get that. Does that make sense?
If it was arc cosine of positive, that university, would you choose the southern part of it?
Then I would be in the first quadrant and I would still have a positive one.
Why did you choose the 5 pi and not
Because of my restrictions. Arc cosine, which is the same thing as cosine inverse, arc sine, the same thing as sine inverse, they say we're only allowed to be in certain places. Well,
or is there like a way to like figure it out?
the way to figure it out is what portion of the arc you have to choose, the inverse you have to choose before it starts failing the vertical line test. But I think for most people that's not a shortcut. You know what I mean? So could we do a little like arc sine 1 and 4, arc cosine 1 and 2? I mean, you could do a little jingle like that. But sadly, the reason why I think it's more complicated for most people than just the, oh, I'm looking here and here. Arc tangent, I'm looking here and here. Arc sine, I'm also looking here and here. It is earlier. So I'm not going to ask you to fill in the blank, but in that question, you needed to know to pick 5 pi over 6.
Doesn't have to be in the arc.
Arctan and arcsine have the same one. So if you know arcsine, which you probably should, arctan be the same. So, I would say arctan is a good thing to know because didn't I mention the asymptotes of tangent you need to know? And the asymptotes of cotangent? So you should know these guys for him anyway.
Oh, is it just reverse?
Because what happens?
Oh.
So tangent's the easy one because it's just in between asymptotes. Sine and cosine, I'm literally like cutting off random pieces of the wave. But tangent's just as asymptotes. Anything else on that list that I gave you guys that you want to see, or is anybody in the review and you're like,
Are we gonna need to know like how to balance or make the one side this?
no,
Like, okay.
no, chapter 5, which, don't worry, chapter 5. Did you guys hear Megan was asking about, do we have to do that whole weird proving and like having to make one side match the other? Chapter 5. That's kind of like Emily's question with the cosine squared and stuff. Let's leave that. Yeah. I think I have a spare one over there too. But you can grab yours out in the hallway. I also have one that's underneath the cart. Either one. Anything else? Okay, I'll pull up the review, guys, on the screen. That way, if someone is stuck on a problem, you can just ask me. Totally fine. But otherwise, if you're all right, I'll go ahead and just leave you alone to let you work. I'm here today until 5-ish, period 7 after school. You guys are the only kids with tests tomorrow, so if there's something you want to ask. Or if you want to come in and work, I'll be available. Okay. I'll freeze the screen, I'll pause the video. You guys are stuck on number 13. It's not as hard. In some ways as the one up there. So it just says go to degrees, minutes, seconds. So I'm not going to radians. I don't need one of those funny multiplications. I just need my calculator to help me out. So I would have my 198.4. And that really cool menu that Sophia produced. If you want, second app has a go to DMS for me, so I don't have to do it by hand. Here for your 7, I'm here after school. I'm technically here during lunch, but for mission trips. But anyway, if you guys need me, come find me. I'll try to help. I have a mission trip meeting, but I'll try to help with this question. Or 7th grade graphics.